In this video, I'm going to be talking about increasing and decreasing functions in regard to calculus. So on this first problem, it says write down the interval where the graph is, where the graphs are increasing and decreasing. So for this particular graph, when we talk about the interval, we're just talking about the domain. So we see that the graph is increasing. It is increasing from 0 included all the way to infinity, and infinity is not a real number. So we use parentheses. If we look at the, and then it's not decreasing at all. If we look at the next one, the graph is only decreasing, and it is decreasing from -2, not included because we have a hole in the graph, all the way to 3, which is included. And then the next one, we have this graph is increasing and decreasing, so we're going to be increasing from -infinity all the way to 2, and then decreasing from 2 to infinity. Now, some of you might be a little bit confused and think, well, at 2, how is the graph, because I used a bracket, that means that it's included, and so some of you might be looking at this and saying, well, this doesn't feel right, because how is the graph increasing and decreasing at 2? And the explanation is that the graph, we're just looking at the interval. From the interval from -8 to 2, the graph is increasing and decreasing from 2 to infinity. So trust me, you use brackets, not parentheses for this particular problem. If there's a hole in the graph like this over here, we're going to use parentheses. So let's look at the next one. If we look at this problem here, we see that the graph is always increasing. Now at this particular point right here, the graph has, it's a stationary point where the slope is 0, but nevertheless we're going to say that the graph is increasing. We're going to say it is increasing from -infinity all the way to infinity. Now if we look at the next one, the graph is increasing from 1 to 5, and it is decreasing from -infinity all the way to 1, and then from 5 to infinity. We're just looking at the domain, right? So this is included. If we look at the next one, the graph is increasing. The graph is it's decreasing here, it's decreasing here, it's increasing here. We always read a graph from left to right, and if the graph goes down, it's decreasing. If the graph goes up, it's increasing. So the only place that, well, it looks like it's increasing here, and it's increasing here. So the graph is increasing from 2 to 4. 4 is a vertical asymptote, so that's not included. And 2 is included. And then we're also increasing from 4, which is not included, all the way to infinity. The graph is decreasing from -infinity to, I'm assuming this is y equals 0, so 0, and that's a vertical asymptote, so that's not included. That's also decreasing from 0 to 2. Great, let's move on. Number 2 says find the interval where f of x is increasing and decreasing. I'm going to skip the first one. I hope you recognize this as a parabola that opens up and down. It's centered at the origin, so that one's super easy. Now this one's also going to be a parabola, and I know it's a parabola because this is quadratic. So I'm going to find out where the vertex is. I'm going to find out where my slope is 0. So I'm going to take the derivative of this. I'm going to take f prime of x equals 4x plus 3. I'm going to make my slope 0, so I have 0 equals 4x plus 3. I'm going to solve for x. I'm going to subtract 3 to both sides, and then I'm going to divide by 4. So that gives me that x equals -3/4. So my turning point, the vertex of my parabola, is somewhere, I don't know, over here somewhere, where the turning point or the vertex is at -3/4, comma something. I don't know what the y is, but it doesn't really matter because we're looking at the interval, which is the domain. So I'm going to do what's called a sign diagram, and I want to figure out whether the slope is positive or negative on both sides of this stationary point at negative 3/4. So I'm going to find some value here, say, I don't know, negative 10, and I'm going to plug it into my derivative function because I want to know what the slope is over here on the left-hand side of this turning point or my vertex. So let's do negative 10. So I have 4 times negative 10, that's negative 40. Negative 40 plus 3 is going to be negative 37, which is negative. So on this side, we have a negative graph. That makes sense. We're decreasing. And then what happens on the other side? Let's find some value. How about a positive 10? So 4 times 10 is 40, plus 3 is 43, so that's positive. So the graph, it decreases as a negative slope up until this negative 3/4, and then it reverses and it becomes positive. Another way we should have known that this is a parabola that opens up is that the leading term here is positive. If we have 2x squared, that is going to be a positive value. So we are going to be decreasing, well, let's start with increasing. Increasing from negative 3/4 to infinity, and decreasing from, it's decreasing from negative infinity to negative 3/4. Let's do another one. I'm going to rewrite this so it's f of x equals 2 times x to the power of negative 1/2. So when I take the derivative, this is going to be super easy. So the derivative of f of x is going to be equal to, move the exponent to the front and multiply. So I have 2 times negative 1/2, which is going to give me negative 1 of these x's. And then to the power of, subtract 1 from the exponent, that gives me negative 3x. Which is, if I wanted to rewrite this, is going to be negative 1 over x, x squared, but it's the square root of x cubed. So if I plug in, let's do a sign diagram. And we see that if my slope is 0 right here, then what is my x value that will give me 0 over here? Well, it feels like it's going to be 0, but if it's 0, if I have a square root that is 0, that gives me 0. That gives me 2 over 0, which is undefined. But there's definitely a vertical asymptote at 0, so that's important. We're going to keep track of that we have a vertical asymptote there. But it doesn't look like we have a slope of 0 anywhere. So let's find out what's happening on the left-hand side of this 0. We're going to plug in some value. How about, I don't know, negative 1. Let's plug in negative 1. So I plug in negative 1 here. I have the square root of negative 1 cubed. Well, negative 1 cubed is negative 1 times negative 1 times negative 1, which is negative 1. Well, the square root of negative 1 is imaginary. So on this side we have imaginary numbers. And then what happens on the other side? Let's take some value and plug it in. How about, I don't know, how about 2? I'm going to plug in 2. The square root of 2 cubed, well, 2 cubed, that's 8. The square root of 8 is, well, a positive number. And then I have 1 over the square root of 8, which is going to be a positive number. But then I have this negative, so I get this negative value. So the graph is going to be on this side over here. It looks like we have a negative slope. So the graph is going to be decreasing over here. And so we converge on this value over here, but there's nothing going on over here. These are all imaginary numbers. So I want to throw this into our calculator just to take a look at what this would actually look like. So if I have y equals 2 over the square root of x, yeah, that's all we have. We have this one piece of, it looks like a hyperbola with a vertical and horizontal asymptote. So let's move on to the next one. Oh, so we're just decreasing. I should say that we're just decreasing. Decreasing from 0 to infinity. 0 is not included, it's a vertical asymptote, and negative, or infinity is not a real number. I have e to the x. Now that's something you should be able to recognize as well. It's just an exponential graph that looks like this. So we should see that the graph is always going to be increasing from negative infinity all the way to infinity. That the graph is increasing. Now, if you wanted to do a sign diagram, then we take the derivative of e to the power of x, so that would be the derivative of so the derivative of e to the x is just e to the x. And then we try to, so we make this 0, and that 0 equals, well, e to the power of x. What is this x here that will give me 0 over here? Well, there's nothing I can plug in for e to the power of x. There's nothing I can plug into here that's going to give me 0. So there is no stationary point for here. No stationary point. So for this graph just continues up. So we go from, we increase from negative infinity to infinity. All right, let's continue. Let's look at some more problems. We have this f of x equals negative 2x cubed plus 4x. We're going to do the same thing. We're going to take the derivative of it. That's going to give us negative 6x squared plus 4. And then we're going to find our stationary point. We're going to make our slope 0. So 0 equals negative 6x squared plus 4. We're going to subtract 4 from both sides. So that's going to give us negative 4. And then we're going to divide by negative 6. So that gives me negative 6 equals x squared. That's going to give me positive 2/3 equals x squared. And then we take the square root of both sides. So I get x equals the square root of 2/3. So my stationary point is going to be at the square root of 2/3. Now what's happening on the left-hand side of the square root of 2/3? Well, let's try 0. 0 is going to be an easy number to plug into our slope. So I'm going to plug in 0 here. So I have 0 squared, that's 0. And 0 times negative 6 is 0. And so I have this plus 4, so that's going to be positive. We're positive on this side. What happens on the other side? Let's plug in some value. How about, I don't know, 2. I'm going to plug in 2. So if I plug in 2 here, I get 2 squared, which is 4. 4 times negative 6 is going to give me negative 24, and then plus 4 is going to give me negative 20, so that's a negative. So that means that our graph is going to be increasing. It's going to be increasing to this point, and then it decreases. So it looks like there's one other mistake that I made here. Whenever you take the square root, though, we need to remember to take the square root of, we need to remember plus or minus. So this should have been plus or minus the square root. So there should have been some other value over here, which makes me a little bit suspicious now whether I did this right or not. So we have another, the square root of negative the square root of 2/3. So I need to find, I had to find a value in between these, and I did. I chose 0, so that makes sense that this should work. Now I have to find some other value on this side of this stationary point of negative the square root of 2/3, which we'll say, I don't know, negative 10. So I'm going to plug in negative 10 here. Negative 10 squared is going to be a positive 100, and 100 times negative 6 is negative 600. Negative 600 plus 4, that's going to be negative. So I have a negative over here on the left-hand side of this negative 2/3. So we're going to, it looks like we have a slope over here that's negative, and then it becomes positive over here. So we have what's called a local minimum here and a local maximum here. So our graph is going to be decreasing from negative infinity all the way to negative the square root of 2/3. I apologize. And then we're also going to be decreasing again after the square, I should say these are going to be included. And then we're going to be decreasing again from the square root of 2/3 all the way to infinity. That's where we're decreasing. And then we're increasing, the graph increases between these two. This is our interval where we're increasing. We're increasing from negative the square root of 2/3 all the way to the square root of 2/3. Now, we could throw this in our calculator and check, but I'm not sure if I'm going to spend the time to do it. You're welcome to go to Desmos and find out. So let's do another one. This is going to be, we could actually graph this using our transformations. This would be, because this is e to the power of negative x, that's a reflection across the y-axis. So what used to be this here is going to now become this here. And then it's plus 3. It means the graph is going to go up 1, 2, 3 units. So we're going to converge on this y equals 3. So the graph should look something like this. So it looks like it's always The graph is always decreasing. So we only decrease from negative infinity all the way to infinity. We're going to be constantly decreasing. Now, if we wanted to do the derivative of this, we see that, well, I'll just go ahead and do it. So we have f prime of x equals 3 goes away, and we end up with so e to the power of negative x, the derivative is e to the power of negative x, and then we have to take the derivative of the inside function, which would be -1, so I have a negative here. So we could make this 0 again, so I have 0 equals this quantity here, but there's nothing I can plug into here, this x value, that's going to make this a 0. So it's not, we'll never have a stationary point. We'll never have a slope of 0. There is no value for x that will give me, that goes with any exponent, right? I could have 2 to the power of x. There's no x value. There is no x value that I can plug, there's no value for x I can plug in that's going to give me 0 on the left-hand side. That's just how exponentials work. That for all exponentials, there's no x value that will make the left-hand side 0. So this is where we are decreasing. We're decreasing from negative infinity to infinity. Let's look at the next one. So I'm going to take the derivative of it. So f prime of x equals 12x cubed minus, we have to multiply this, 16 times 3, 18, 3, 4, 48. So I have negative 48x squared, and then plus 48x, and then the negative 2 goes away. So where are my stationary points? Well, I have a 0 here, equals, and it looks like it can factor out some stuff. It looks like it could factor out a 12. I can also factor out an x. So I'm going to factor out this 12 and the x, leaving me with x squared behind, and then 48 divided by 12, that gives me 4, so I have negative 4x, and then plus 4. So it looks like I can factor this piece here. That's going to give me 12x times the quantity of, well, what times what gives me 4, but when I add them I get negative 4. That would be negative 2 and negative 2. Negative 2 times negative 2 gives me a 4, and negative 2 minus 2 gives me negative 4. So my stationary points are going to be at 0. If this x here is 0, then 12 times 0 is 0, and then all of this multiplied by 0 gives me 0. So we have x equals 0. And if this x here is 2, then 2 minus 2 gives me 0. 0 times the rest is going to give me 0. So I have another stationary point at 2. And of course, if this x here is 0 as well, then we get, 2. I get 2 minus 2, which gives me 0. And 0 times the rest will give me 0. So I have 2 stationary points, one at 0 and the other at 2. So I'm going to use my sign diagram, find some value to the left of the 0. How about, I don't know, how about negative 10? If I plug in the negative 10 here, then I get a negative number. 12 times negative 10 is a negative number. If I plug in negative 10 here, negative 10 minus 2 is going to give me a negative number. And then if I plug in negative 10 here, negative 10 minus 2 is going to give me a negative 12. That's a negative number. A negative times a negative times a negative is a negative. So on this side, we have a negative slope. Find some number between 0 and 2. How about 1? Plug in 1. 12 times 1 is positive. Plug in 1 here. 1 minus 2 is negative 1. That's negative. Do the same thing here. Negative 1. 1 minus 2 gives me negative 1. That's negative. So I have a positive times a negative times a negative. Negative times a negative is a positive. Positive times a positive is a positive. So I have slopes that are positive here. And then after the 2, some number, how about, I don't know, 3. Let's plug in 3. If I plug in 3 here, 12 times 3 is positive. And then plug in a 3 here. 3 minus 2 is going to give me 1. That's positive. Plug in 3 here. 3 minus 1 is 3 minus 2 is 1. That's positive as well. And I have a positive times a positive times a positive, which is a positive. And so all of this is positive right here. So what this means then is that I have a negative slope here, and then at 0 it becomes positive. So we have a graph that goes down and then becomes positive at 0. And then we flatten out, and I have a stationary point. This is actually called a stationary inflection point. And then it becomes positive again. So this is what our graph looks like. And because it's cubed, it makes sense, to the power of 4, our leading term is to the power of 4. So that means that both ends are going to either open upward or open downward. So we have a graph that looks something like this. So we are going to decrease. Let's do increase first. So increase, we're increasing from 0 to, well, infinity. So increase we have lots of room over here. So we are increasing from 0 to infinity. And we are decreasing from negative infinity to 0. Let's look at another one. Oh, this is our answer then. Let's look at the next one. So we have x cubed minus 6x squared plus 3x minus 1. And we're going to first take the derivative of this. So I have f prime of x equals 3x squared minus 12x plus 3. We are now going to find out, we're going to find our stationary points where our slope is 0. So I have 0 equals 3x squared minus 12x plus 3. I can factor out a 3. That's going to give me 0 equals 3 times x squared minus 4x plus 1. And to me it looks like we're going to have to use, in this case, what times what gives me 1, but when I add them I get 4. I'm going to have to find, in this particular case, I'm going to have to use the quadratic formula of x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, where a is 1, b is negative 4, and c is 1. And so I'd have to actually plug all these in. So I get negative b plus or minus the square root of b squared minus 4ac all over 2a. So negative is a positive, plus or minus the square root of negative 4 squared, negative 4 times negative 4 is 16, minus 4, all over 2. And that gives me 4 plus or minus the square root of 14 over 2. And then we have, well, that's going to give us some, we could throw this in our calculator and get something that's a little bit more like a decimal point equivalent. But if I have the square root of 14 times 7, I actually can't, it looks like I can't do a factor tree with that. So this is going to just be some ugly irrational number, and so we're just going to have, we have 2 of them on both sides, and so this one's going to be a little bit more difficult. If you want to do this one, plug this in your calculator and you get a decimal point equivalent. Actually, I'll just do it. I think this is going to be my last one anyway. So I have 4 plus the square root of 14, and then divide by 2. Divide by 2. That's going to give me, we have 3.87. We have some other value where this becomes negative, so I have, make this negative, so I have 4 minus the square root of 14, and then divide by 2, and that gives us this negative, this 0.1292 if we want to. So we could do the same thing. We have, we can do, now we have our sign diagram, and then we find some value to the left. We could say, I don't know, 0. And so if I plug in 0, then plug in 0. So I have 0 squared, which is 0, times 3, which is 0, minus 12 times 0, which is 0, plus 3. So that's going to be positive on this side. And then some number in between. How about 2? If I plug in 2, let's try 2. So if I plug in 2, even 1 would work. I'm going to try 1. I think 1 is going to be easier. So plug in 1. 1 squared is 1. 3 times 1 is just 3. So I have 3 minus 12. So I have 3 minus 12 plus 3. And that's going to give me, it looks like a negative number. If I take some other number, how about 10? Let's use 10. Let's use 10 here. We're going to plug in 10. 10 squared is 100. 100 times 3 is, 300. We have 300. Minus, we're using 10, so minus 12 times 10, that's going to be 120, so negative 120, and then plus 3. You can see that that's going to be positive. So our graph is going to be, we have a positive slope, becomes negative, and then becomes positive again. So we can see in this particular case that our graph is increasing from negative infinity all the way up to, let's use that ugly irrational, so 4 plus, this is going to be minus the square root of 14 over 2. And then we are going to be increasing again from this point here, which is going to be from 4 plus the square root of 14 over 2 to infinity. And then we're going to be decreasing from the values in between. So from 4 minus the square root of 14 over 2 to 4 plus the square root of 14 over 2. So anyway, I hope that this video was helpful, and have a wonderful day.